Welcome to Input-Output with Files or File Operations with C++. In this video, I will show you how to open a file, write to the file, close the file, or open, read, and close the file using the code, classes, and libraries of C++. Basically, C++ provides specific classes to perform output and input of characters to or from the files. First one, OFStream, which is a stream class to write on the files, and then IFStream, which is a stream class to read from the files, and then FileStream, which is a stream class to both read and write to the files. These classes are derived directly or indirectly from the classes you already know, which are iStream and OStream. You have already used objects whose types are of these classes. Remember the cin? Cin is actually an object of class iStream, and cout is an object of the class OStream. Therefore, we have already been using the classes that are related to our file streams. And in fact, we can use our file streams the same way we are already used to with cin and cout. With the only difference that we have to associate these streams with physical files. Let's try an example and understand through an example. So the first thing we need to do is to add the proper header over here. So I'm going to do #include and add the file stream over here. So that's as much as I need over there. And then because I'm going to be using the namespace as std, so I'm going to do using namespace std. There you go. And over here, let's see what are the steps. So the first step is to create an object from the class OFStream or the type OFStream. So I'm going to do OFStream, which is my type, and then I'm going to name it myStream. And you can name it whatever you like. This is just for the sake of this example. And when you create a stream, you need to define where the stream is, okay? But anyway, for the sake of this example, let's say my stream doesn't even exist, so I'll simply create that. And then I'll be like my stream, and I need to open it. When you want to open it, you need to let the compiler know where the file is. In this case, I will be like, okay, it is called the test.txt, and it is existing within my folder. If you don't have the file existing within the folder, what happens is the compiler will automatically create the file. So what happens is compiler checks if the file already exists, and if the file doesn't exist, it's going to be created. So I'm going to go here and say, okay, now on my stream, I technically want to write something to it. Remember how you used to do the cout? So we're going to do the same thing here. I am writing here, and that is pretty much how I'm going to write something to the file, as simple as that. And after I'm done with the file, what I'm going to do is I'm going to do myStream.close, so that stream is closed and gone. And that's pretty simple. Again, within a couple of lines, as you can see, I define an object of the OFStream type, and then I go ahead and open it based on the address it has. And then from there, I'll be like writing anything that I want to that file, exactly as if I'm using a cout. So if you remember, this is exactly what you used to do. You used to do cout the line, right? Or whatever information you wanted to do. Just look at these two. These are identical. So you're not doing anything specific besides using this object, which is an OFStream object, for doing this example. So this code will create a file called test.txt and inserts the sentence into that file the same way that you used to do with cout, and that's pretty much it. But let's go through steps that we need to actually take care of in more details and come back to this example again. So in order to open a file with a stream object, we use its member function open. So in the open, we can have the file name, as you can see, and as we just used it in our example, and then define in which mode you want to open the file. Again, here the file name is going to be a string representing the name of the file to be opened, and mode is an optional parameter with combination of some flags which we're going to review right now. Remember one thing, that the mode is optional, and if you don't use the mode, it's going to open up in the default mode that we're going to discuss about it later in this video. So the open flags are these. So you can either do in, which is open for input operation. You can do out, which means open for output operations. You can do binary to open a file in binary mode and manipulate the file in binary mode, which is very useful in future when you're working with different binary modes from different programs. Or you can do 8, which sets the initial position at the end of the file. So basically that 8 is at end. And if this flag is not set, the initial position is going to be the beginning of the file, which is going to make more sense. So you put it at the beginning of the file and start writing at the beginning. If you set this flag, you're going to be at the end of the file and you can work your way back up. It all depends on which algorithm you're using. Or you can do the app, which all output operations are performed at the end of the file, appending the content to the current content of the file. So that's one of the use cases. Let's say you already have a file that is keeping the information about a project and you want to add more information to the end of the file. You want to make sure nothing is getting overwritten. That's when you use that flag. Or you can use the trunk. If the file is open for output operation and it already exists, its previous content is deleted. Remember that, and replaced by the new file. So it is very crucial to understand what each one of these flags are going to do for you and go from there. Remember, all these flags can be combined using the bitwise operator, and therefore you can add some flags together and take advantage of all of them. For example, if we want to open a file, in this case we call it example.bin, which is a binary file. In binary mode, to add data to the end of it, we could do it this way. So create my file as a stream. Remember, you always need to have this stream created if you're working with the files. And then say myfile.open. So as we said, the name of the file is going to come first. Remember, the name of the file is going to be a string, and that's why you put it inside the quotations. And then from the iOS space, just call out, which means this is going to be an output. And then we use the bitwise operator. Look at that. And then again, we add the flag app, which is for append. All output operations are performed at the end of the file, appending the content to the current content of the file. And then we add another one, iOS binary, which means we are opening it in binary mode. So this can actually continue and get added as many flags as you want. It all depends on the algorithm you're working on. Let's take a look here and see what we can do for the default modes. So each of the open member functions of classes OFStream, IFStream, and FStream has a default mode that is used for the file if you don't use any second argument or flag. So by default, if that's an object of OFStream, the iOS out is set, which means if you have an OFStream object, you just open it, it is already in output mode. IFStream, the same thing, and the file stream is going to be in both. So basically you're saying I want to do input and output on both. Let's go back to our example and look at that. So because we created an object of OFStream without having any parameters sent, as you can see, I don't have nothing going on here. That means it's an input or output. If I want to define it specifically, I can go ahead and put this. and then over here say, hey, go and read from iOS, and let us have it in mode. Okay, so very very simple. Let me just put it back to InType. There you go. So basically that's as simple as that. For now, I'm going to get rid of this because we don't want to do this, and go back to the slide sets. So let's review the slides once more. For IFStream and OFStream classes, iOS in and iOS out are automatically and respectively assumed. Even if a mode that does not include them is passed as second argument to the open member function, the flags are combined. For fstream, the default value is only applied if the function is called without specifying any value for the mode parameter. If the function is called with any value and that parameter, the default mode is overridden, not combined. File stream opened in binary mode perform input and output operations independently of any format consideration. Non-binary files are known as text files, and some translations may occur due to the formatting of some special characters like new line and carriage return, \n/n, and all those characters. So since the first task that is performed on a file stream is generally to open a file, these three classes include a constructor that automatically calls open member function and has the exact same parameters as this member. Therefore, we could also have declared previous object openings that we had, like the example or my file, and conduct the same opening operator in our examples. Look at that. So if I say ofstream my file and name of the file, address of the file, and then put it as out, is app, and it's binary, it's as good as we did before. So combining object construction and a stream opening in a single statement is very, very useful. So everything is happening all at once, all in just one file. So let's go back to our code and see a simple example of that. So over here, remember, I created the object up here, and then I defined it down there. So how about me going up here, and right when I'm creating the object, go ahead and ask the object to be created and open from the address. So then I simply don't need this line to exist, and all is good. So as you can see, one less line if you just take advantage of this, or if you want to add any flags to it, you can continue with adding flags and move on from here. So pretty simple. That is what C++ gives us with combining the object construction and a stream opening in just one command. Just be careful that in this case, if the file doesn't exist, it's going to be generated by C++. So sometimes in your program, you need to check to see if the file is opened successfully. Remember, sometimes you're referring to a file in a folder, and you don't know if the file already exists or not. Maybe the previous operation which is supposed to create the file for you or copy the file for you did not successfully terminate, and therefore what you're going to get is the object doesn't exist over there. To check if a file stream was successful opening a file, you can do it by calling a member of this class called isOpen. So this is the guy that we're talking about, and this member function returns a Boolean value of true in the case that indeed the file stream object is associated with an open file, or false otherwise. It actually acts like a safeguard for you to make sure the file that you're trying to open is already open. Let's see how it actually happens. So in this case, look at the MyStream object that we created through this line, and also we opened through this combination. In this case, if I want to do something on it, let's say these guys down here, it is safe to do this. If MyStream and then I'm going to call the is open one for my stream is open, which is going to tell me, give me true if it is already successfully opened. Then I'm going to take care of all of these guys that I want to do. So I'm going to get these out of here and put them in here. So basically, let me just get rid of this commented one over here, and you can see what's going on in a clean way. So look at that. So I'm basically saying getting as open as true or false back to make sure the opening is successfully happened, and then I'm going to do my file. This is going to handle the possible errors. Think about the situation that my stream is not open and you actually want to execute these two lines. That's not going to work. That's not going to happen at all. Okay, so that's a good thing that you can get from this file is open member. Remember, what becomes even more important at this point is how about when you're done with this? Remember, when you open a file, you actually are taking control of a resource, and then operating system possibly is not going to have no access to it, and so on and so on. So at the end of the day, you have to do the close and make sure this file is closed. So when we are finished with our input, and let me go back and have these guys up and talk about it over here. So yes, when we are finished with our input and output operation of the file, we have to close it. And it's as simple as using the close method of the FStream or IStream or IOStream, which basically does close the file and makes it available back to the operating system or other files that they may want to use this file. So that's pretty much the easiest step. So again, let's review. We open the file, we check if the file is open, we do manipulation of the file, whether that is writing, changing, editing, or reading from a file, and then we close it to make sure operating system gains back the access to the file. So let's talk about text files a little bit. So text file streams are those where the iOS binary flag is not included in their opening mode. Remember that we had the flags, right? So I'm going to go back to the flags pretty quick. So if you use this iOS binary, then they're not going to be considered text file. Any other situation, if this is not there, we still consider them to be text files. And that is a little bit different from the concept that you have about a .txt file, okay? Even if you're writing the comma separated information into it, we still call it a text file. So these files are designed to store text, and thus all values that are input or output from or to them can suffer some formatting transformations. This, as I said before, is something like a character, a backslash, a carriage return, or stuff that we are using may be different between different formats of the text file. Okay, writing operations on text files are performed the same way we operated with cout, and of course, reading from them is going to be the same that we did with cin. Let's see this with an example and work with it in action. So far I have my my stream open as test.txt, and I'm checking if my stream is open. And over here, let me just get rid of all this, and I want to bring this close back to the operations of the if, because remember, if the file is not open, there is no reason to close it. So this is a better place for this guy to be. And then what you can do is you can simply say my stream and go ahead and say this is a line and then \n basically, and terminate the line, and then I can say my stream and write another line into it and say this is another line and do \n, and this is going to update my file. So before we go any further, let's look at some adjustments that you can apply to your Xcode or any other IDE that can make your life easier when you work with the files, and you can copy them to the same folder and work with them. So what I'm going to do is I'm going to go to the menus of my Xcode, and you can find the same menus respectively between all the other IDEs. I'm going to go to the product, and in the product I'm going to click on a scheme, and from the scheme I'm going to go to the edit scheme. So here I get my edit scheme, and from the edit scheme I'm going to go to the options, and in the under the options, again, look, I'm under run options, and under the options I'm going to come down here to the working directory and use the working directory as a custom directory to be the exact same directory that I actually am keeping my file. Let me just cancel this and show you again. So when you check that, you can click over here, there you go, and you're going to get directed to the folder that you have the project already copied in there. So just choose the same folder so that everything in that folder is everything that you create is going to be copied to that. So I'm going to click choose. Now that is chosen over there, it is on the desktop, and let me just go back here, choose this guy. This is where all my files are, right? So I click on it and click choose. Just make sure it is checked properly, and then click close. This way, every file that you're working with is going to be within the same folder, and you're not going to have the issue of addressing. Later down the road, I'm going to talk to you about, yeah, you can do this. You can just put the absolute address of whatever. But in this case, we just set the working directory to be the directory that we are in, and therefore everything is going to be happening right over there. So I'm going to run this pretty quick, and as you can see, it works without no problem. The file is open, no problem has happened, and we're all good to go. So now let's take a look at where the file is. So I'm going to open up my Finder pointing to the same project folder. And as you can see, the test.txt is right here. So I'm going to double click on it and open it with my text editor. And as you can see, let me just minimize this. As you can see, both things that I wanted to write into this test.txt is already over there. This is a line, this is another line. So let's do this. Let's add something else to my stream and be like, okay, put down, this is the third line, and I'm gonna do something like a carriage return here, and if I run this, it successfully is gonna happen. And now I'm gonna go back to, let me just close this guy, and I'm gonna go back to the file that I have, and you're gonna see it's updated. So it's over here. So if I double click on it and bring it back here, yeah, you see this is the third line. So as simple as that. So you can have multiple files within that folder and work on those guys right over there. And then now let's go here and close this guy. And what I'm going to do is I want to read from this file and see what is inside the file. Since the file already has information, and let me bring it back here. Since the file already has information over here, so we should be able to read that information. So let's go here, and within the code, I want to add some lines so we can basically create this. Okay, so in this case, what I want to do is I want to read information from the file into a parameter and then show them on the output. That means I'm going to need to have a string. I'll call it the line because it's going to be reading the line for me. And then this time I'm going to go to the ifstring data type. Remember, input file. While up here I had an output file, so input file, and I call it my file. Let me just make it even easier. And to open that, notice that it's very easy now because I know it's test.txt, right? So I'm just putting the address for test.txt over there. And this is going to open it for me. Okay? And then I'm going to check and say, hey, if my file that is open is true, which means you are successfully in the stage that the file is opened, I'll create a loop and say while, remember how we used to read information from the line? It was through this very good guy called getLine, right? So I'm going to do a getLine over here. And then instead of cin, we used to put a cin in here. In this case, I'm going to put a my file. And where do I want to read it to? Line. Very simple. You see that? So basically, this while is going to check if I still have something in the file to read. And in that case, since I have something to read, I'm going to be like, okay, see out the line. And just to make it nicer, as we always try to do, we can simply just do an end line over here. And that's pretty much what we want to do. So after this while, I'm going to be done with the file. So what I'm going to do is I'm going to close my file. So it's going to be my file.close, and there you go. So what if the file is not open? In that case, I will be like, hey, else I want to let the user know that something is wrong, right? So let's do a cout over here and say, hey, unable to open the file. And there you go. And just to make it nicer, there you go. So let's see what we did. So starting here, we created a string line. Then we created an ifstream object, name it my file, and we opened it by connecting it or mounting it to the test.txt of ours. Then we say if my file is open, which in this case we are checking that if ifstream was successful in opening test.txt. Inside, I'm creating a loop, which this loop basically reads my file. Remember, and let me just put it down here for a second so you can see. So if I wanted to do this like the past, that would have been cin, and that would have been line. So this was what I would have done if I wanted to read that from the input from the keyboard, right? So as you can see, the same thing, just my file is substituting cin, and the line is right over there. So basically, let me come back here. Excuse me. So the get line is going to read it from my file, which is a stream mounted to the test.txt, and read it to the line. And then I'm going to see out the line, end line. That's simply just printing it out to the output screen. And then when I'm done, I'm closing the file. And if I cannot find the file, obviously I'm going to go out and I'll let the user know that the file is not open. Let's run this and see what we get. So as you can see, now I get this is a line, this is another line, and this is the third line, which I basically got. Let me just open that guy again for you guys. So this is how the file looks like. And as you can see, exactly what you see in the file is now presented over here because you read it line by line. So pretty easy, pretty straightforward. Just remember that this is the exact same thing that you did with cin and cout. So just to wrap it up, this example reads a text file and prints out its content on the screen. We have created a while loop that reads the file line by line using the getLine. The values returned by getLine is reference to the stream object itself, which when evaluated as Boolean expression, as in the while loop, is true if the stream is ready for more operations, and false if either the end of the file has been reached or some other error has occurred. So as soon as this while loop gets to this point, which is the end of the file, it's going to stop reading. And as you can see, we don't get any empty lines over here. So let me just do something pretty quick, and that's I'm going to go here and delete the test file. Let's just move it to the trash, and I'm going to empty my trash so no trace of it exists. And in this case, I'm going to go ahead and run this program again. And as you can see, I get the same result. Why is that? Is because, as we said up here, when you want to open the test.txt and the compiler figures out that test.txt doesn't exist, it automatically creates one, which then is this guy. over here that is doing very well. So now let's do another experiment. I'm gonna close this. I'm gonna delete this guy. Okay, and get rid of it. Empty my trash. And then what's going on is I'm gonna come back here, take this creation, and comment it for the sake of this experiment. Now the only part of code that I have is opening and reading. Let's run it right now. And as you can see, build is successful, but it's telling me unable to open the file because in this case, the file does not exist. And this one is going to return a false. Therefore, I'm going to jump to the else, and else over here is going to print this out. So pretty straightforward. That's a check you always have to do just to make sure you're not just going after nonsense, because if we wouldn't have checked this and program would have arrived at this point, the file doesn't exist. You do a while, nothing is being printed, and you don't even know why. So I'm going to go back here and put this back to life once again, run it once again, and now this time you should see all the lines that you entered. So that's pretty much about that. So now let's talk a little bit about checking the state flags which are available within ifstream and ofstream. I'm going to go back to the PowerPoint and let's look at this. So the following member functions exist to check the specific states of the string. Remember, all of these ones are going to return you a Boolean value, which is going to be very helpful if you use it in an if statement and check it. So you can have my stream.bad, which returns true if reading or writing operation fails. My string.fail, which is true when same case as bad happens, but also in this case, a format error may happen and you get that error, like when the alphabetical character is extracted and you were looking for integer. So what happens in bad is if you cannot read or write, that's going to be true. For the fail, it only happens when it happens on top of bad, especially if you have data type incorrectness, reading a string and now you're getting something like integer. So for end of file, obviously it talks about itself. It returns true if file open for reading has reached to the end, so you can basically use it. But remember, when you are reading, if you reach end of file, it automatically doesn't continue. And then good, it's the most generic state flag that returns false in some cases, in which calling any of the previous functions would return true. Note that good and bad are not the exact positives. Good checks more state flags at once, and the member function clear, the final one, actually is used to reset the flag. So if you want to reset the flag, you can always use the member function clear and go from there. And using them is very easy. Let me just go back to the code and show you. Like here, instead of saying if my file is open as true or false, you can just check, I don't know, if my file.bad and go from there. So as you can see, that's as simple as that. Or if my file.good. These are the flags that you can use. It all depends on what program algorithm you're using and what are the needs of your programming algorithm. Or like you can do end of file. Pretty simple, huh? It's like one of the simplest things that you can do if you already know how the C in and C out work. You just need to map your knowledge to this new system, and that's it. So now let's talk about get and put stream positioning. Let me go back to the slides and talk about those with you guys. These are important. Remember, all iOS stream objects keep internally at least one internal position, so they all know which position they're starting. You can think of the iOS stream as as a reader needle of a gramophone or something like that always starts at one specific position, and that position is being kept by the object. So ifstream, like iStream, keeps an internal get position with the location of element to be read in the next input operation. So if I go back here, I can tell you that in case of the file that we had, let me see if I can quickly open that file again. That's right here. So when the program starts reading, you can see the blinking cursor. That's going to be the get position for iStream. And when you finish the first line and you go to the next line, and this while over here is actually adding one more line of operations, then your get position moves to where the blinker is right now. It's very useful if you want to change it or jump over something and do more complicated file manipulations or file operations. But for now, that's as much as we are going to go through it. So the OFS stream, like OS stream, keeps an internal put position. So the same thing, but this time that's the position that next character is going to be put in. Remember, in these streams, we are reading character by character, or we are writing character by character. So like if the position is here right now, the next character to be entered or written to this test.txt is going to be substituting or overriding I. As you noticed here, it didn't matter how many times I run the file or the code, it always gives me the same 3 lines. It didn't add it because I didn't open the file in the append mode. If I want to add lines after this, I have to open the file in the append mode. But here I'm in the insert mode, the default mode, and that means I always start to have my get or put position at the beginning of the file, and therefore the override was happening every time I was running this program because of that positioning. So finally, file stream keeps both the get and the put position like iOS stream. And let me get back to the slides for you guys so that you can have a visual over here. And basically understanding where the get or put position is going to help you distinguish and differentiate between if you want to overwrite or if you want to append and stuff like that. The internal stream positions point to the location within the stream where the next reading or writing operation is performed. These positions can be observed and modified using TELG, TELP, SEEKG, and SEEKP, which basically is TELGET and so. So let me just go and show you how you can change those positions right over here. So these two, the TELGET and the TELPUT, basically they have no parameters. They return a value of the member type stream position. So this is a new type that we're introducing here, which is a type representing the current get position in the case of the TELGET, or the put position in the case of the TELPUT. So with just running those get TELGET or TELPUT, you can basically get back where your position in the file is. Remember that when we were talking about the objects and classes, we said there is a getter or setter. Basically, you can consider this TELGET and TELPUT as the getters of the fstream or IO stream, which the return type of them is a stream position. Pretty straightforward. Then we have the SEEKGET and SEEKPUT, which these functions allow to change the location of the get and put position. The previous two functions basically just give you the position. These two are simply giving you the option to change the position. Like if you want to jump over a couple of characters and so on, you can use these. So both functions are overloaded with two different prototypes. The first form is SEEKGET and you pass the position to it, or SEEKPUT and you pass the position to it. So basically you can define where is the next character that's supposed to be read from or supposed to be written into. Using these prototypes, the stream pointer is changed to the absolute position. Remember, that is absolute, is not relative. So it's going to count from the beginning of the file. And if you do so, basically you're jumping to a couple of characters after the point that the last character was inserted into. The type for this parameter is stream position, which is the same type as returned by functions tailget and tailput. The other form of these functions will be SEEKGET. You put an offset and the direction. So this one is not absolute. So in this case, wherever you are, you can put a direction and the number of characters that you want to jump back and forth. Using this prototype, the get or put position is set to an offset value relative to some specific point determined by the parameter direction. Offset is of type stream offset, and direction is of type seek direction, which is an enumerated type that determines the point from where offset is counted from. And that can take any of the following values. So it can be beg, which goes for the beginning, so offset counted from the beginning of the stream, or offset could be counted from the current position with cur, or end, which offset could be counted from the end. Let's go back to the code and practice this with an example, so make it easier and more understandable. So in this case, I want to go ahead and do this. I will come up here and define a stream position, STREAMPOS, and again, as I said, it's a STREAMPOS type. So STREAMPOS, and it's going to be a begin. I'm going to add another end because I'm going to need both of them for this matter. Okay. And did I do a typo? Oh yeah, I have a typo over here. So here you go. So STREAMPOS, begin and end. And now I can use that with whatever stream that I already have created. So let's go down here. And remember, we created a my file over here, not right? So what I'm going to do is I'm going to set the begin to be my file dot. Remember, I'm getting the current position through using the tailget. And just to show you what it is, I'm going to go ahead and print begin. And I'm going to add an inline. There are two actually nice things to remember over here. So what's going on over here is the begin, which remember was a stream position type over here, is my file, which is my stream over here on the test.txt. And basically that goes to the position that is already there, and it tells me where the position is. What you would expect at this point in the code is for the position to be end of the file, which means where the file is over. And what I'm going to do over here is run the program to show you what we're going to get. But before I go there, let's see what you guess the number is going to be. Take a moment and think about what the position is going to be. Yes, you're correct. The position is -1. I'm pretty sure most of you guys didn't guess it, but let's do this pretty quick. And as you can see, the position shows -1 down here. So when you arrive at the end of your stream reader and the file, that's the position -1. I will actually go ahead and copy this just for a second and add it over here after I add a line. So let's do this. So basically, I'm just showing where am I writing in that file. Let's run it again and see how it works. So as you can see now, every time I write something, I can see which position I'm starting the next line. So this is a line, and then at position 18, I'm starting, this is another line, position 42, another line, 68, another line. And then finally, when I get to the end, I show -1. That shows this file is over. I read all the way throughout the file. So as you can see, it's very simple to use tailget or tailput or stuff like that with just calling them as member functions of a class. With the knowledge of object-oriented programming, this is nothing just but a new class that you're using with the functions that are available to you. Let me just get rid of these two guys over here and go from there. So basically that's how it was. I run it again, so my program goes back to what it was, and it's pretty much as good as new. So as you noticed, stream position is a specific type used for buffer and file positioning and is the type returned by file.tailget. So values of this type can be safely subtracted from other values of the same type or added to the values of the same type. So we can do all arithmetic operations over the values that you get from the stream position. Let me just go back here and talk about it a little bit. So the stream positioning functions use two particular types, a stream position and a stream offset. So these types are also defined as member types of the stream class. So stream positioning, this is how you define it, iOS, and then it's position underscore type, which defines a file position member, and it can be converted to or from stream offset and can be added or subtracted value from or to values of these types. And then the stream offset itself is an alias of one of the fundamental integral types, such as integer, long, or so on. So what you actually can use here and take away from this a little bit complicated slide is that when you get stream positioning values, that size, that number, you can add them, you can subtract them, and you can use them in any type of variable calculations that you have. So let's go and start talking about the binary files and see how the file operations work over the binary files, okay? So for binary files, reading and writing data with the extraction and insertion operators and functions like getLine is not sufficient. Remember, you're talking about binary, not the text anymore. Since we do not need to do format for any data and data is likely not formatted in different lines over here, getLine and such are not going to work. So file streams include two member functions specifically designed to read and write binary data sequentially. So you have write and you have read. The first one, or write, is a member function of OSTream inherited by OFStream. And read is a member function of iStream. As you can guess, respectively, go back to the classes that are meant for input or output. Objects of the class fstream have both. So if you have an fstream object, then you can use both. Look at the prototype. So basically we have write, and then we define the memory block and the size, or we have read from the memory block and the size. Memory block is of type character. That's a pointer to a character, actually, a character pointer, and represents the address of an array of bytes where the read data elements are stored or from where the data elements to be written or taken. The size parameter is an integer value that specifies the number of characters to be read or written from or to the memory block. So to reduce the confusion over here and get it more understandable, let's jump to the code and see how actually we can work with that. So just for the sake of this one, I'm going to get rid of most of the code that we used to have, make it simpler so we can start almost from scratch. So we still need the iOS stream, we still need the file stream, and we still need to use the namespace instead. So in the main, I want to create a stream position and name it size. So basically that's the size I'm going to work with. And a char pointer, and I want to name the pointer memblock because I'm working with memory blocks. I think that's a cool name for that. And then I need an ifstream file. I name it file. And then let's call it, I don't know, let's say example.binary, something like that. And because remember, this is going to be an input file, and this also is going to be a binary file, and this also is going to be starting at the end of the file, just for the sake of this example, so that you can see how you can easily create a stream and open the stream at the same time. So I'll check if the file that is open is true. So basically, if I have a file which is open, and then what I'm going to do is I'll check the size with file.tellg. So basically, I want to see where am I in the file, where's my position. Okay. And then the mem block is going to be a new char. And remember, we're talking about a pointer here, right? So I'm putting it in an array of size, which I already defined up here. What is the size? And then I'm going to do a file.setGet. And in the file.setGet, let's start from the offset of 0. And that offset of 0 is going to be from the beginning. Okay, how about that? So, and then I'm going to read the file.read. Remember, we said read is what you use in order to actually input. And in this case, the mem block is going to be read to the size. And with that size, sorry. And then I'm going to close the file. Okay, so I'm closing the file. And then of course, let's see if we can have the result of it. So what I'm going to do is I'm going to put a cout over here, which that cout is going to be the entire file content as in memory, because if I can read from the beginning to end of it, that means the entire file is in the memory. And then at the end, remember, you have to delete that array pointer that you created. And then if this is not the case, which means my file is not opening, so I'll be like else cout, like what we did before. We want to just say that we cannot open the file, right? Unable to open the file. And I'm gonna go ahead and close it right over here. Basically, that's all I want to do. Perfect. So let's see what we get if we run this code. Well, successfully built, and now you see that you're unable to open the file because I don't have the file available over there. And it is obvious because I never created that example, that bin. So what I'm going to do just for the sake of this one is I copy that name and I'm going to go to the folder. And I'll simply just rename this guy to example.bin. And just to show that the file is over there and it's asking me, hey, you're going to have problems. No, use bin. So now that the file is in there, if I come back here and run this again, now you see it tells me the entire file content is in the memory because it's able to see it. And now you can see how easily you can actually call in different methods and functions of stream readers in order to look at the memory and manipulate the memory. Just remember, in this case, you need to have a pointer to the memory block because you really don't want to use the addressing over here and do the absolute addressing because it's not going to work. So let's go back and talk about the buffer and the synchronization a little bit. So when we operate with file streams, these are associated with an internal buffer object of the type stream buffer. Basically, we are not going to use a stream buffer and manipulate it that much in this level, but it's good for you to know that this buffer object may represent a memory block that acts as an intermediary between the stream and the physical file. For example, with an OF stream, each time the member function put, which writes a single character, is called, the character may be inserted in this intermediate buffer instead of being written directly to the physical file, with which the stream is associated. The operating system may also define other layers of buffering. So when the buffer is reaching to a specific threshold, then basically it's going to be written. So when the buffer is flushed, all the data contained in it is written to the physical medium. Instead of writing it character by character, so basically you buffer it somewhere and then you write it all at once when you flush the buffer. This process is called synchronization. So when you synchronize, basically you're flushing the buffer to the file or bringing the information you read from the file to the program. So synchronization happens when file is closed. Before closing a file, all buffer that have not yet been flushed are synchronized and all pending data is written or read to physical medium. It also is done when the buffer is full. Buffers have a certain size. Therefore, when the buffer is full, it automatically gets synchronized. And it happens explicitly with manipulators. So when certain manipulators are used on streams and explicit synchronization takes place, these manipulators are flush and end line. So either you do flush or end line, at that point synchronization happens, or it can happen explicitly with member function sync, which calling the streams member function sync causes an immediate synchronization. This function returns an integer value equal to -1 if the stream has no associated buffer or in case of failure. Otherwise, if the stream buffer was successfully synchronized, it returns 0. And that's all that we want to cover in this video regarding the file operations. You can get very easy with file operations after a couple of practices and writing a little bit of code or debugging a code. Like everything else, practice makes perfect. Thank you very much for watching this video.